Now, conformance resources. So these are meta resources used to describe how systems should behave and what codes or values sets they use. So they're essential for semantic interoperability and automated validation. Some key resources of conformance we'll discuss. First, we have a capability statement. So it basically advertises what a FHIR server or client supports, which resources, which operations, supported search parameters, supported formats like JSON or XML, security, and supported profiles. So we have some important fields: status date, FHI version format, software implementation, and scrutiny. Sorry, security. This is the example JSON for capability statement. So where do we use it? So clients check capability statement to know how to interact with the server. For example, can I create observations? Which search parameters are supported, etc. Then structure definition. Purpose is to define or constrain the structure of a resource, a profile. You can make fields mandatory, restrict value sets, add extensions, annotate, must support. Example scenarios: India core patient profile, US core condition profile. Use validators like HAPI, Inferno, validate resources against structure definitions. Then we have value set and code system. So code system is basically a full vocabulary, for example, SNOMED CT or LOINC, which enumerates codes and their display strings. And then we have value set, which basically is a curated subset of codes used for a particular purpose. For example, all LOINC lab tests for CBC, often referenced in resource fields via binding. Then we have example binding. Observation.code might have a required binding to a LOINC value set. Then we have operation definition, which describes custom operations like method name, input, output parameters hosted by the server. For example, everything match for patient matching. Next up, we have infrastructure resources. So they support API level infrastructure tasks, packaging messages, auditing, and asynchronous notifications. First, we have bundle. So bundle is basically a container for multiple resources. We have some types like transaction, which is atomic. Then we have batch, non-atomic. Then document, message, and collection. So the usage of a bundle, key usages. So first in transaction, the server must process all or none. Then document, clinical documenting composition plus contained resources, and messaging event with header intended for messaging flows. Then we have list. So it is basically ordered collection of references, not necessarily an exchange, more like a curated view. For example, a patient's medication list or a problem list or a list of allergies, right? So list.item entries reference resource IDs. Then we have audit event. So it basically records security or audits data, who did what, when, where, and why. Fields, type, subtype, action, recorded agent, a source entity, right? And usage is basically compliance with local regulators like HIPAA audit trail. Then we have subscription. It allows clients to request notifications for resource changes that match a criteria. For example, new observations for a patient. Channels, REST hook, HTTP post to endpoint, WebSocket, email and SMS, etc. Pitfalls: security of callback endpoints, verifying endpoints to prevent abuse, large fan out performance. Then we have document reference, a metadata pointer to clinical documents, often the narrative stored externally or in binary. Example: discharge summary PDF contains content or attachment with URL or inline binary reference. Then we have administration resources: who, where, when. High level administrative resources handle identity, location, roles, scheduling, and workflow orchestration. Patient: key elements, identifier, name, gender, birth date, address, contact, managing organization. For cross-system exchange, patient identifiers plus identifier system URI are critical. Avoid using display names as unique identifiers. Then practitioner is the person, doctor or nurse with identifier name and qualification. And practitioner role, connection of a practitioner to organization, role or location, availability, and specialties. Then organization is basically the entity, the hospital or the lab, and location is the physical space, the ward or the room. And we link them via organization.part of or location.part of. Then encounter represents an interaction between patient and the healthcare system. Fields we have like status, the class, ambulatory or inpatient, type, the subject, the period, participant, reason code, right? Usage, tie observations, procedures, medication administrations to a care episode. Pitfalls: ambiguity around what constitutes an encounter. Some systems create many small encounters. Then we have appointment, which is booking, and schedule, which is general availability schedule. Slot represents the availability block. Order versus service request, right? So use service request to request diagnostic or procedural services. Then on the fourth point, we have the clinical resources. So this is the largest and the most critical domain. I'll explain the common ones field by field with examples. So first we have observation. Purpose is to record a measurement or assertion made about a patient, lab result, vital sign, questionnaire or response, questionnaire response. Important fields: code, what is measured, usually the LOINC code. Then subject, which is the patient reference, effective and X with when measured, date, time, period, effective time, right? Uh, then value of X is the value quantity, value string, or value codable concept. Then we have the component list for compound observations, BP systolic or and diastolic, and reference range. So for example, BP, we have this as the JSON code, right? Moving on, condition, it represents a recorded clinical condition, problem, diagnosis, or even a health issue, which is active or has been resolved, right? Both are put in condition. It has fields like code, the SNOMED CT code, clinical status, verification status, onset, When did the condition start? Abatement and evidence list and subject, right? Then we have diagnostic report. It aggregates observations, lab tests into a report, includes issued result, references to observations, conclusion, presented form in PDF format. Then we have medication request, which is prescriptions or orders for medications. Medication statement, assertion that the patient is taking or not taking a medication, often patient reported. And medication administration, record that a medication was actually administered in patient. So these are the key fields. Medication codable concept or medication reference, RX norm, dosage instruction, status and subject. Then we have allergy intolerance document. It basically is used to document the allergies or adverse reactions. Fields are substance, clinical status, verification status, reaction list. Right. Then we have procedure. Record that a procedure occurred. Contains code, subject, status, and performed X. Then we have care plan. High level plan of care. Goals, activities, service request, procedure, participants. Right. Then we have finally the financial resources for the billing and claims. Claim is basically structure for submitting charges. Key fields are patient, provider, item list, as the services that have been provided, total amount, and diagnosis list. Requires coding systems like ICD-10 for diagnosis, CPT for procedures, and national taxonomies. Coverage and explanation of benefit, EOB. Coverage basically is policy or insurance details, and explanation of benefit is basically insurers' adjudication of a claim, what was paid or adjusted. And then we have account, invoice, payment notice for more detailed financial records, invoices, insurance, and accounting. So that's all about our conformance resources. What is the difference between observation.code, LOINC, and condition.code, SNOMED? So observation.code identifies what was measured, LOINC for tests, and condition.code identifies the diagnosed problems, SNOMED CT is suitable. Name 3 resources that you would include in a discharge document bundle. We have patient encounter and composition with document reference or diagnostic report, condition list, and medication statement. Right. When would you use bundle type transaction versus batch? Use transaction when operations must be atomic, all succeed or all fail. Batch when operations are independent. Okay, now some quiz 3 questions and answers we'll discuss. So Anscombe's quartet experiment exemplified that similar correlation between two variables x and y does not imply similar data distributions. So Anscombe's quartet is 4 data sets that have nearly identical descriptive statistics, that is means, variances, correlation coefficients, and linear regression lines, yet have very different distributions and patterns when plotted. So Anscombe's quartet basically 4 data sets having nearly identical descriptive statistics, but very different distributions and plots. The lesson is that numeric summary statistics, that is these descriptive statistics alone, can be misleading. Always we need to visualize the data using plots. So it also implicitly demonstrates that correlation alone tells you very little about the underlying relationship, and that statistical summaries can hide non-linear patterns, heteroscedasticity, and outliers. So why option A is not the best here? Basically, while the quartet aligns with the general idea that correlation is not causation, the quartet specifically emphasizes that similar summary statistics, including correlation, do not imply similar data sets. So similar correlation between two variables x and y does not imply similar data distributions, is the Anscombe's quartet problem in essence. Right. Moving on, interpretation of strong positive correlation basically implies nothing. Nothing can be inferred from this, because correlation measures linear association, Pearson correlation, or more general monotonic association, using Spearman. It does not indicate causation. Reasons: reverse causation. Y could cause X when founding a third variable Z causing both X and Y, and coincidence or sampling bias. To infer causality, you need experimental designs, randomized trials, causal models, directed acyclic graphs with causal assumptions, instrumental variables, or strong domain knowledge, plus conditional independent tests. Right? Example: ice cream sales and drowning both increase in summer, but correlation, there is correlation, but it is not causal. Now, conditional probability notation, we have this: P smallpox given spots, basically having smallpox when spots were observed, right? P A given B, probability of A given B, probability that event A occurs conditional on event B having occurred. So probability patient has smallpox given they have spots, right? Moving on, probability of a hypothesis before considering the observed data is basically posterior odds is basically prior odds times Bayes factor, right? Now, Bayesian network structure is a directed acyclic graph. So it represents probabilistic relationships between variables using a directed acyclic graph, where nodes are the random variables and directed edges indicate conditional dependencies, parent to child. Acyclic, no directed cycles are allowed, prevents circular definitions, and ensures we can factor the joint distribution. Right? PCA affine transformations used. Which affine transformations are used to generate a new coordinate system in PCA? The answer is rotations, and centering, which is a translation step applied before PCA. So PCA principal effect is the rotation of axis to align with directions of greatest variance, principal components. Mathematically, PCA finds the eigenvectors of covariance matrix. Projection onto eigenvectors rotates the coordinate basis. However, PCA typically also centers the data. That is, subtracts mean before computing covariance. Centering is a translation of origin. So both occur in the workflow, that is centering, translation, and then rotation. Right. Moving on, Bayes' rule provides a framework for updating probabilities based on new evidence. It's the foundation of Bayesian inference. Compute posterior distributions for parameters or hypotheses, not directly for causation. Causal inference requires causal models and assumptions, which is not representation learning approach. So, representation learning broadly means learning features or representations of data that make tasks easier. PCA, yes, reduces dimensionality. Unsupervised representation learning, word embeddings, word to vec, Glove, yes, these are representation learnings. They represent words as vectors. Bayesian networks primarily are a probabilistic graphical model for representing joint distributions and conditional dependencies. They are not primarily representation learning in the sense of learning continuous vector representations. Although they encode structure, they are not usually listed under representation learning approaches. Right? So they encode dependencies by conditional probability, not continuous embeddings. Now, three node structure in Bayesian nets. We have causal chain, serial A to B to C, conditional independence, right? A independent of C given B. Example, genetics, cholesterol and heart disease. Genetics influences cholesterol, which influences heart disease. B mediates the effect of A on C. Then common cause diverging from C to A and B. C is common cause of A and B. So we have conditional independence. A is independent of B given C. Example, weather C causes road wetness A and slippery roads causing accident B. Here C causes both, that is rainy weather. Then common effect, collider or converging A to C and C to and A to C and B to C. So marginally independent, but conditioning on C makes them dependent. Two independent causes A and B can create a common effect. For example, A is flu, B is allergy. C causes the cause, that is runny nose. Observing runny nose makes flu and allergy occurrences dependent. If runny nose is present and you learn it's not allergy, belief for flu increases. Now we have finally PCA details step by step, which we'll cover in the next lecture.